In this video, let me consider one numerical on node analysis. Find V1, V2 and V3 using nodal analysis. This is the given circuit. So this is the given circuit. Here voltage at this node is V1, voltage at this node is V2 and voltage at this node is V3. We need to calculate these three voltages using node analysis. Here we can observe that in between V1 and V2 there is a voltage source. This is current dependent voltage source. It is dependent on current I, and I is the current which flows through 4 ohm resistor. Since the voltage source is connected between V1 and V2 directly, we can say that V1 and V2 are supernodes. Similarly, in between V1 and V3 there is a 12 volt voltage source is connected directly. Therefore V1 and V3 is also supernodes. So here V1, V2 and V3 all are supernodes. Let me write, that is here V1, V2 and V3 are supernodes. So now we need to analyze supernodes first. Here we can say that V1 minus V2 is equal to 2I. That is V1 minus V2 is equal to 2I. So here I is nothing but V3 divided by 4. I can write V1 minus V2 is equal to 2 into I3 is nothing but V3 divided by 4. That is V3 by 4. Or I can write V1 minus V2 is equal to 2 by 4 is 0.5 V3. Or I can write V1 minus V2 minus 0.5 V3 is equal to 0. Let me call it as equation 1. So here we can observe that there is a voltage source between V1 and V3. Therefore V1 and V3 are also supernodes. So we have to analyze supernodes first. I can write V1 minus V3 is equal to 12. So V1 minus V3 is equal to 12 volts. Let me call it as equation 2. So we know that if the nodes are supernodes, then algebraic sum of currents at supernodes is 0. So that we know that algebraic sum of currents at supernodes is equals to 0. So let current through this branch is I1. So here there is a voltage source. Let current through this branch is I2. Anyhow current I3, I is flowing here. So we can say that here at node V1, I1 is the current which is outgoing. At node V2, I2 is the current. Here we can see there is let current through this branch is I3. So now let me identify the currents at particular nodes. So at V1 the current is I1. So I can write at V1 we have current I1 is outgoing. Let me take outgoing current as minus I1. Similarly at V2 the currents are I2 is outgoing, I3 is outgoing. So let me take it as minus, that is minus I2 and minus I3 are the outgoing currents. Similarly, and at V3, so here we can see that at V3 current I3 is incoming, current I is outgoing. Take incoming current as positive, outgoing current as negative. So I can write plus I3 and minus I. So according to this definition, that is algebraic sum of currents at supernode is 0. That is sum of these all currents is equal to 0. Therefore, that is minus I1 minus I2 minus I3 plus I3 minus I is equal to 0. Or I can simplify this as minus I1 minus I2. This I3 will get cancelled. Minus I is equal to 0. Now we need to express these currents in terms of node voltages. So I1, so here I1 can be represented as V1 by 4. or I can write minus V1 by 4. So I2 is nothing but V2 by 1, that is I2 is V2 by 1, and I is V3 by 4, that is minus V3 by 4 is equal to 0. Or I can write V1 by 4 plus V2 by 1 plus V3 by 4 is equal to 0, or I can write 0.25 V1 plus V2 plus 0.25 V3 is equal to 0. Let me call it as equation number 3. So these are the three equations. Now we have to solve these three equations to find V1, V2 and V3. That is solving equations 1, 2 and 3 we get. So now let me use the calculator to solve these equations. So go to the mode, choose equation mode, that is 5. Here we have three unknowns, V1, V2 and V3. So we should choose this equation, that is option number 2, that is 2. So here feed the values. Here A, B, C are with respect to V1, V2 and V3. So in first equation, coefficient of V1 is 1. So this is 1 is equal to coefficient of V2 is minus 1. Minus 1 is equal to coefficient of V3 is minus 0.5. That is minus 0.5. And we have D. D is nothing but this value, that is 0. 0. Now the cursor will go to the second equation. So now feed the values for the second equation. Here coefficient of V1 is 1. Here V2 is missing. It means its coefficient is 0. Coefficient of V3 is minus 1. And D value here it is 12. Similarly, here coefficient of V1 is 0.25. Coefficient of V2 is 1 equal to coefficient of V3 is 0.25. And this value is 0, that is 0 is equal to, again press equal, so it gives x, that is first unknown is V1, V1 is minus 3, V2 is 9 by 2, that is 4.5, and V3 is minus 15. Therefore I can write V1 is equal to minus 3 volt, V2 is equal to 4.5 volt, and V3 equal to minus 15 volts. So this is the required result. Thank you for watching.